Gravity is a fundamental force of nature. It is everywhere. It is invisible. But its effects are all around us. Gravity holds us to the Earth. It keeps the moon in orbit around our planet. Gravity even shapes the vast expanse of the universe. Understanding gravity is key to understanding how our universe works. It governs the motion of planets, stars, and galaxies. Gravity is a force of attraction between any two objects that have mass. The more massive an object, the stronger its gravitational pull. Gravity also depends on distance. The closer two objects are, the stronger the gravitational force between them. This force weakens as objects move farther apart. Gravity is a universal force affecting everything in the universe. Throughout history, scientists have sought to understand this invisible force. From ancient Greek philosophers to modern physicists, the quest to unravel the mysteries of gravity has driven scientific inquiry for centuries. Long before Isaac Newton, ancient scholars pondered the nature of gravity. The Greek mathematician and inventor Archimedes explored the concept of the center of gravity. He realized that objects have a point where their weight seems to be concentrated. Centuries later, the Italian scientist Galileo Galilei made significant strides in understanding gravity. Through his famous experiments dropping objects from the Leaning Tower of Pisa, Galileo demonstrated that objects of different masses fall at the same rate, neglecting air resistance. This finding challenged the prevailing Aristotelian view that heavier objects fall faster. Galileo's work paved the way for a new understanding of gravity, one based on observation and experimentation. These early pioneers laid the groundwork for a revolutionary understanding of gravity. Their insights provided a foundation for future scientists like Isaac Newton to build upon. Sir Isaac Newton, born in England in 1642, is a towering figure in the history of science. His contributions revolutionized our understanding of the physical world. Newton's work on gravity is inseparable from his three laws of motion, fundamental principles that govern the motion of all objects. The first law states that an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and direction unless acted upon by an external force. The second law explains how force, mass, and acceleration are related. The third law states that for every action, there is an equal and opposite reaction. These laws, combined with Newton's law of universal gravitation, form the bedrock of classical mechanics. They provide a comprehensive framework for understanding how objects move and interact with each other, from the smallest particles to the largest celestial bodies. Section 4. The Apple and the Moon, a story of universal gravitation. The story of Newton and the apple is one of the most famous anecdotes in the history of science. As the story goes, Newton was sitting under an apple tree when he saw an apple fall to the ground. This simple observation sparked a profound realization. Newton wondered if the same force that pulled the apple to the earth also held the moon in its orbit. Could this invisible force extend beyond the earth to govern the motion of celestial bodies? This question led Newton to formulate his law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This means that the more massive the objects and the closer they are, the stronger the gravitational attraction between them. Newton's law of universal gravitation provided a mathematical explanation for the observed motion of planets and other celestial objects, solidifying his place as one of the most influential scientists of all time. Section 5. Gravity's reach from celestial bodies to everyday phenomena. Newton's discoveries about gravity had profound implications, extending far beyond a falling apple or the moon's orbit. His work provided a new understanding of the cosmos, explaining the motion of planets, stars, and galaxies. Gravity is the architect of the universe, sculpting the large-scale structure we observe today. On Earth, gravity is responsible for everyday phenomena we often take for granted. Tides, for example, are caused by the gravitational pull of the moon and the sun on the Earth's oceans. The moon's gravity pulls the water on the side of the Earth facing it, creating a bulge. This gravitational force also creates a corresponding bulge on the opposite side of the Earth. These bulges are what we experience as high tides. Low tides occur in the areas between the bulges. Gravity's influence is all around us, shaping our world in countless ways.